My talk today is on extremophiles. So just from the word, you may ask yourself, well, what is an extremophile? You might think of an extreme sport or maybe something like this. Even though this mouse is trying to do something extreme, this is not an extremophile. After researching the subject on extremophiles, I was able to find a lot of information on the subject and a growing collection of research that would benefit humanity. I will inform you on the definition, the history, some of the uses, and some types of extremophiles. The definition from Miakarta is an organism that lives in extreme environments where other life forms cannot survive. Extremophiles were first found in Yellowstone National Park by Thomas M. Brooke. Since that time, research has, and scientists have been studying them for their benefits to man and for their possible harmful effects to humans. Many types of extremophiles are, for instance, thermophiles, like found in Yellowstone National Park, that can withstand temperatures of 250 degrees Fahrenheit. They dine on hydrogen sulfide and organics. Radiodurons, like this one, nicknamed Blueberry, can withstand 1,500 times the lethal dose of radiation that would kill a human being. It was first discovered by a researcher attempting to do radiation cured for food processing, and after 4 hours of radiation, the extremophile came back to life by repairing its DNA. This is an example of an acetophile. For instance, this is lactobacillus, and it creates lactic acid. There have been found living in mines in the state of California and in toxic pools of cadmium, arsenic, copper, zinc. Another type of extremophile is psychrophile. Its claim to fame is that it lives in extremely cold temperatures, like in the Arctic, Antarctic, and survives there just fine. Another type of extremophile is halophile. And this is a picture of the Great Salt Lake, and the red is low water tide. And it creates, it basically lives in 10 times the salinity of the ocean. Another type of extremophile is baryophiles. And they live in high pressure situations at 700 atmospheres at the deepest parts of the ocean. This extremophile is tardigrade. That's also nicknamed a water bear. It lives on lichen and moss, and what makes this organism extreme is the ability for it to withstand droughts. What it does is it loses 99% of its water and creates a waxy surface around its outer layer. And in this state, it can actually withstand drought situations. And what ends up happening is it basically relies on the wind or an animal to come by, pick it up, to carry it somewhere else. Prince Impey, of astrobiologist from the University of Arizona, referred to this tardigrade as the Godzilla of extremophiles. And the reason he did that was because scientists have been testing the extremes to which this water bear can actually survive. And they have frozen it to minus 328 degrees Fahrenheit and as high as 300 degrees Fahrenheit. And at this high temperature, or high pressures as high as 1,000 atmospheres and near vacuum. British scientists performed this experiment by sending this one to space, opened up to the vacuum of space and the radiation from the sun, and when they brought it back down, it was able to survive and breed and live a long life. Some of the uses of extremophiles are the government used them for in 3,000 Superfund cleanup sites to render toxic metals inert, lactic acid production for the cheese process of cheese, for cellulose, ethanol formation, and to relieve our dependence on foreign oil. Some other uses include paper bleaching, food processing, bioremediation, desulfurification, and antibiotics. So in summary, extremophiles are organisms living in environmentally extremes and were first found in Yellowstone National Park. Scientists are now finding many uses for extremophiles. I've been able to give you an overview of extremophiles and some of their uses. With life living at such extremes, scientists have been able to postulate environments that may exist on other planets. But that's a topic for another speech.